Everyone, welcome back. This is Anu here. Today, I'm going to discuss about another new topic that is related to WebSocket versus Rust. In the previous video, we have seen what is difference between HTTP and HTTPS, and after that, I have discussed the Rust API from scratch. What is meant by Rust API? What are the advantages of the Rust API and all? What are the endpoints used in Rust API and all? And in another video, I have shown the difference between REST API, Graph Query Language, and gRPC, and what is the payload differences between them and all. And today, I am going to discuss another topic that is called the WebSocket versus Rust. Rust is another one API which is successfully everyone is using nowadays. But if you imagine if you're using any um WhatsApp message or any other messaging interface, okay. Um, Users are chatting simultaneously. We can see the other person is chatting. We can see the other person is typing something, right? It is giving that notification. In this kind of mechanisms or platform, we are not using the Rust API because Rust API's payload is high, and every time we need to send some message, it has to initiate from beginning onwards. And the payload, I am going to show you the payload, how much payload for the Rust API. Let's see here. This one I have already shown before in the graph query language versus Rust versus gRPC. Let's run this one. See this Rust API response it taking around 842 bytes whenever there is a request. This example, it is I'm just getting two requests. For this two requests, it is taking this much amount of data bytes for doing the data transfer and all. That what I mean to say is the payload for the REST API is high, and whenever we want to do some communication using the REST API, if it is if it is REST API, it has to go to this HTTP endpoint, put update and all those kind of jargons. It is going to be a heavy, hectic process. Why? Because every time the server has to process this REST API request over the globe, around billions of users are using and this WhatsApp at a time. If 800 bytes are required for one communication or one message transfer, it's going to be hectic for the system. So to avoid that, they can use something called WebSocket. WebSocket means once the connection is established, it will be persistent until they close the communication, and they can restart the communication at any point of time. This is what this WebSocket. Okay, let's go ahead and see what is this WebSocket and how can we use this WebSocket instead of REST API in WhatsApp kind of messaging systems and all. Okay, if you see the comparison between REST API and WebSocket, it is one directional. The client will ask client will request to the server, and server will respond back. It's a one directional. At a time, only one communication will happen. And if you consider about the WebSocket, it's a two-way communication. Anyone can send any message at any point of time. Only one time the handshake is happening, whereas in REST, every time if they want to communicate, they have to do the handshaking. In WebSocket, once the handshaking is done, it will be connected all the time. This is what the difference between REST API and WebSocket. Let's see the difference. Client asks the server. Client asks, server answers every time. That is, every request is a complete end-to-end communication. Whereas in WebSocket, one upgrade, one handshake. After that, the system is connected throughout. The connection closes after each. Whenever the response is completed, the connection will be closed. Whereas in WebSocket, connection will not be closed. This is here. It is a full duplex in WebSocket, whereas in REST API, it's not full duplex. It's a one-way communication. Then let's see the data flow of REST and WebSocket. If you see how this REST is pulling the data, we have the client connected to the server. First, it will send a get request. Client will get send a get request message to the server, and it will be connected using the communication protocols, and it is giving the status code 200 if it is successful. Once it is done, it will close the connection then because that communication is over. Again, if you want to send another get communication, again the new message has to be sent with all the payload. Then again, the communication will start again. The server client, it will send the response code. If it is successful, 200 response code will be sent, and it will be sending the details back. The problem is new TCP TLS handshake pool has to happen every time. 99% of the requests return nothing, and massive waste of data and scale. Whereas in WebSocket, if you see this WebSocket flow, this is also connected to client and server. Okay, client server, the HTTP upgrade request is happening. Then 101 server client, that is 101 switching protocol. It is connecting switching the protocol from HTTP to WebSocket. Now the WebSocket is active instead of a REST API. WebSocket connection is active. Now it is a persistent connection is open. Now this connection is not going to close anywhere. And okay, now the clients can communicate each other. Client one will start messaging, client two will start messaging. In between, again, client two can send message. It is not going to end. Okay, it's a push method from the server side. It will push. This is what this WebSocket communication is. If you see the WhatsApp architecture, you have the phone A, and it will be sending to the WebSocket gateway, and the phone B is the another client, WebSocket client. Two clients are there. It is communication is happening through this WebSocket gateway, and the data will be saved in the message store. Usually it will be in the Cassandra, and the delivery services will be through push and retry. And let's go ahead and see this live demo of the WebSocket. Is a live demo application. I have used HTTP to create this application. This is using WebSocket. I'll easily say hi. Immediately we are receiving this request here, and from here, hello, how are you? You have received this message immediately. Fine. Fine, thank you. This is what this WebSocket communication. This is the same interface we are seeing in the WhatsApp chat and all. How we are communicating. This is what this WebSocket. How the WebSocket is used in a real-time chat application or real-time other applications like gaming podcast and all. Architecture-wise, phone A and phone B are connected through WebSocket gateway. Millions of persistent connections are there, and message store in the backend. We are saying the message in the Cassandra, and delivery we are using server-side push. And all the communications are encrypted end to end because in WhatsApp and all, the communication will be encrypted before the data go outside the device. In-device encryption is happening. Okay, also we use this WebSocket in trading system, multiplayer games, live dashboard, and collaboration tools, etc. And if you want to see the architecture of how this WhatsApp is using this kind of system, let's go ahead and see the complete architecture. This is a 7-layer architecture. No, not 7. It's a 12-layer architecture. If you see, um, the first layer is client. Okay, user facing application, iOS, Android, web, or desktop. Then client components are there. There's a local logic, that is user interface, connection manager, end-to-end encryption, cryptography, and local databases. And next come to the transport, that is transport layer security, the TLS security, a binary protocol, and WebSocket TCP connection. Then fourth layer is the edge, that is scaling and routing, that is for the load balancer or fan out recipients and all. End-to-end encryption, that is signal protocol, pre-key and sender keys are used. A pipeline for the reliability, queues and debug events are queues, debug event bus are used for this pipeline. For microservices, that is a domain logic. All the services use microservice architecture, not the monolithic architecture. I will explain in another video what is the difference between monolithic and microservice architecture. What the microservice architecture means, each and every services will be controlled by separate uh, repositories rather than a single repository handling everything. If suppose in WhatsApp business is a separate repository, WhatsApp broadcasting will be separate repository, like that. Each one will be handled with separate team, or the complete application will be connected together using the API endpoints. media, files, and voice notes. That is a upload, download, content delivery network, and encrypted blobs. Persistence, durable state, that is Cassandra and in-memory session states are using. Push notification, FCM, APNS, that is reconnect socket connections are using. And OBS, that is for the production health monitoring, logging, and abuse detection. Okay, these are the uh, architecture layers in WhatsApp kind of any messaging application. Let's go ahead and see the architecture a little bit in detail. And the first layer is called the client application. Client application can be WhatsApp in iOS, Android, WhatsApp Web, or WhatsApp Desktop. And then that communication will come to the layer 2, that is a client side components, that is chat UA, contact groups, and all. They will be sending the media or either they can send the media or preview or watch the media. That will go to the media and cache preview session. And these are get from the blob storage, encrypted blob storage will be there. From there, it will be getting and giving to the users. If there are signal protocols, I use these signal protocol client that is used for encryption and decryption of the data. The local storage will be there. That is a local encrypted storage will be there in client side. Then there is a connection manager that is for the persistent socket. That is a WebSocket connection manager is there. This connection manager will handle the persistent connectivity between client 1 and client 2. That is always pushing the registration. Then we come to the third layer, that is a transport layer security, where we are using TLS 1.2 and encrypted channel. And there it is using custom binary protocol and WebSocket connection and level of TCP connections are used. Then the layer 4, that is the edge and ingress, that is for the data ingression. Global load balancers are being used for supporting millions of customers, and edge point of pressure or geo-routing station will be transferred to that point of pressure and to the connection servers. Then in stage 5, this connection request is going to the a real-time messaging core, that is a session manager. The session manager, the request will be transferred to two layer. One is message router or dispatcher. The message has to be routed either to persistence, that is online. We can see whether that particular person is online or whether it is typing or what is the last seen time and all. Or fan out means one is to one message will be sent to multiple users. That is called the broadcasting kind of thing. That is called the fan out. And delivery recipients, and we will get the notification double tick delivered, read or not. That is how the message router. And apart from that, this message router or dispatcher will give request to different endpoint or API endpoint and to do this WhatsApp business API. Let's discuss that later. Fine. Then we'll go to the layer 6. Layer 6 is end-to-end encryption service. We are using different encryption mechanism for doing the encryption, a center key group or double react algorithm or key rotation and session reset and pre-key bundle server. These are the mechanism used for doing the end-to-end encryption. Then we can see we can go to layer 7. Layer 7 is message and pipeline queue. And from this layer 5, that is message queue or dispatcher, we need to send the message. That will be given to this one, that is message ingress. Okay. Then it will be given to deduplication and ordering, or either to this one, duplication and ordering. Then it will go to the offline message. Suppose if the user is offline, then it will go to the offline message queue, so that whenever that means the user is not online, but the system has to process the data and send it. Then it will go to the queue, and once the queue will be processed one time, whenever the user online, they will get all the messages. That is it is going through retry and backup logic. And after that, if it is not offline, then internal event bus is there. That will be giving user and identity and access management services, contact address book, and group management services and all. And from there, these are the group management details, user details, and identity and access management, and group details and profile status and all. All this data will be saved in the backend Cassandra database, and for this messages and all, we are using hot cache, that is with a Redis limit, a rate limit, and for in memory we are using Minisa as in memory state store. For the Cassandra, there will be backup and for the disaster recovery, there will be backup and replication. And from this layer 7, let's go ahead and from layer 7, we have this layer 8. In the layer 8, we have this identity and access management, and there itself, we are handling this WhatsApp business API, and whether to do this content moderation or something block or report or content moderation has to happen. These are all happening in layer 8. Let's go and see what is in layer 9. Layer 9 is media pipeline. What are the data we are sending that has to go to the end user in the next level, right? Client A has to send a message to client B or number of client C, D, right? That has to go through this one media upload server and media download server, and that upload and download data will be encrypted end to end. And this then it will do the thumbnail and transcoding. Transcoding means different format depend upon the bandwidth and all. The transcoding format will change. Then it will get to the content delivery network or object storage. It's layer 9. Layer 10 we have already seen, that is the data and persistence. Let's see that layer 9, layer 11. Layer 11 is the push notification. Once the user send the message, it will go to the push orchestrator. Push orchestrator will either FCM will be used for Android, or APNS it will be used for iOS to push the notification. Then silent push, that is silent push means if the end user is offline, it will silently push instead of in the WebSocket, it will silently push the data to the device. Once it is done, then it is again going to the connection manager and push the token for registration. And this is layer 11. In the layer 12, we can see the observability. Layer 12 is for the observability. All these activities will be monitored using metrics and monitoring, contain centralized logging, spam and abuse detection, alerting, and SLO tracking and all. This is all about the overall architecture of WhatsApp kind of system where the WebSocket is being used. This is how it is happening. Hope you understand what is meant by WebSocket and what is the difference between REST and WebSocket. What are the advantages of using WebSocket, client side and server side communication, and I hope you understand the architecture of WhatsApp kind of a system. This is all about this WebSocket versus REST API. Thanks for watching this video. Have a good day. Bye.